Oh yeah, here we go into chapter 4, lesson 4.1. What's it all about? Antidifferentiation and indefinite integrals. And then I write this cryptic message of we're going backwards to go forwards? What? Well, let's just think in the general picture, the big picture. Every step of your math learning, you have learned to go forwards and then you learned how to go backwards. For instance, you learned addition, then you learned subtraction. You learned multiplication, then you learned how to undo that with division. And there's other examples of that as well. Well, you've learned differentiation. Now we're going to learn how to anti-differentiate, undo the derivative. Oh, it's sweet. So let's jump right into a problem. Given f prime of x equals 5x to the fourth, find a function f of x whose derivative is f prime. So we're basically saying the derivative of what gives me 5x to the fourth? Well, if I took the derivative of x to the fifth, the derivative of that would be 5x to the fourth. So that is one value for f of x that would work. You could also technically do like x to the fifth plus any constant, like plus 9 would work because the derivative of any constant goes to 0. So what those are called are particular antiderivatives. So the next question is, how many antiderivatives of f prime of x are there? How many different solutions? Well, there's infinitely many constants, right? We could add or subtract any number of numbers. And so we would write that as x to the fifth plus c. And that would be the general antiderivative. And I guess I'll put that down there as well. So the general antiderivative is f of x equals x to the fifth plus c. That c is called, and I'll write it out here for you, the constant of integration. Very cool. So whether you take the antiderivative or you integrate, those are the same things. They're synonymous words. So this is the constant of integration. This is known as the general antiderivative. That's all. And that's because we could have any constant and the derivative of it would be 0 and we'd still get 5x to the fourth. That's going backwards. That's undoing the derivative and saying, where did we come from to get that derivative? That's big. All right, let's keep firing away here. So here are some graphs of the particular antiderivatives of 5x to the fourth. Remember that the particular antiderivatives all fit this mold of the general antiderivative of x to the fifth plus some constant. What happens when you add plus c? Well, here's x to the fifth right there. If I add 1, we shift everything up 1, or add 2, or add 3, or add 2.7, or subtract 1, 2, 3, or any number of constants. Infinitely many solutions to this. Gives you an idea of the family of all the antiderivatives of 5x to the fourth. So we need that plus c every time you antidifferentiate, because if we don't have it there, we're not considering all the possible solutions. We'll get into how to figure out and pin down the exact c value later on. All right, let's keep rolling. We are crushing. Okay, so yet more terminology in all of this. Basically, I'm calling it other ways of expressing what we just did. We could also be asked for the general solution to the differential equation. So let's go back here. The differential equation is still this, right? So we could have also written it as dy dx is equal to, so it's dy dx, 5x to the fourth, and find the general solution to that, right? So that's another way of looking at all of this, and I'll erase that there. So that's just a different way of saying anti-differentiate. So to find the general solution to this differential equation, all we're doing is saying, well, the derivative of what gives me 5x to the fourth? That's the same exact thing again as we just did. And I went back to the last page to show you that. Our particular solution to the differential equation is still the same exact thing that we found. So the general solution we saw from before is x to the fifth plus c. That doesn't change. You call it y, you call it f of x. A particular solution, pick a c value, any c value. It doesn't matter, I'm going to randomly put minus 2.5. So again, those are the general solutions here with the constant of integration and the particular solution. Nice. All right, a differential equation, in formal speak, is any equation that involves derivatives of a variable. So we've been making these equations up until this point by taking derivatives. So you've actually been creating them. For instance, we've taken the derivative of sine and gotten cosine. We've taken the derivative of something and gotten 3x minus 1. We've taken the derivative of something else, we'll get to that down the road, and you get 1 over x. These are all considered differential equations because there are derivatives in the equations. That's it. That's all a differential equation is, so don't make it all highfalutin and difficult on yourself. And this page, which I gave you a sneak peek to just a little bit ago, where it says find the general solution of the differential equation dy over dx equals 8 cosine x. What does that really mean? What it means is anti-differentiate this, and I'm going to show you some new notation. The symbol for take the indefinite integral or anti-differentiate is this. It's like a stretched out s. We'll see why it's a stretched out s down the road. So if I integrate both sides with respect to x, what I'm technically doing, is I'm integrating both sides of this with respect to x. And for right now, y'all, this is just a symbol. That's all you need to know it as. So I'm taking this, the integral with respect to x at both sides. That's how we solve that differential equation. Okay, well, what is, basically we're saying, how do I undo dy dx by dx? Well, the dx's coincidentally kind of cancel out, but not technically. All right, the hardcore math people are going to be like, no, they don't. Let's just think of those as canceling out the dx's. So we'd end up with the indefinite integral of dy equals the indefinite integral of 8 cosine of x dx. All right, where does that lead us to? Well, we're saying the derivative of what got me dy? Well, the derivative of y got me a change in y. And now we're saying the derivative of what gave me 8 cosine x? Well, the 8's just chilling, right? That's just a coefficient. And the derivative of what gives you cosine? The derivative of sine gives you cosine. So your answer would be 8 sine x. Got to have that plus c, that constant of integration, because we don't know exactly where on the graph this thing settles. We saw that with the graph of x to the 5th. That's it, right? It's another way of saying anti-differentiate. All right. Last but not least, a rundown of that notation. To solve any differential equation, we take the indefinite integral, it's just the symbol for anti-differentiation, of both sides of the equation. So for instance, here, I would take the integral of dx of both sides. The integral of this becomes y, as we saw here. The integral of f prime, we're saying the derivative of what gave me f prime? F, right? The derivative of f gave me f prime, plus c. Again, we don't know where we go on that graph. And that's it, y'all. And I wrote it down here where you've got, and you know what, some of that's kind of blocked, so I'm going to move all of that a little bit so you can see it. Look at that. You can now see the indefinite integral with respect to x is the same as the antiderivative with respect to x. That's how that's read. That was a lot of information, right? But you got this. So a nice introduction into what the antiderivative is. The derivative of what got me whatever this number is. Oh, and by the way, fancy pants term, we call this thing that we're taking the integral of the, well, integrand. All right, enough for now. See you in the next video. Peace.